All right, so we got a question here, homework problem that we're going to take a look at. Let's see. Doug, this is your question. Why don't you get us kick-started? Tell me something that we know so we can get kind of some traction here. Cool. Square root of the denominator is annoying. Let's dodge it for now. What can we work with? We have, say that again. What about the numerator?
Square both the numerator and the denominator.
You want to square the numerator?
Yes, sir.
How come? Okay, so we're trying to get rid of the annoying square root. Be careful about the rule for being able to do something at the bottom and do something to the top. Let's do an example. 1/2, right? Is that the same thing as 2/3? So we're only able to do some things to the numerator and the denominator. Those things being a way of scaling it. If you take a look, I can make a video available if anybody wants. You just send me an email for it. Here's the reason for that. 1/2 is literally saying that I have one of two pieces. And if I want to make this look different, I can, without changing the quantity of that piece, like if it's a brownie tray, I could split it in half and I just get two of these smaller pieces, which is why I get 1/2 is the same as 2/4, the same as 3/6, because I'm not changing the quantity, I'm just changing the size of the cuts and the number of cuts that I need to make that happen. So I can multiply or divide on the top and bottom the same thing. That would work out okay. So you multiply, can't add, can't subtract, can't square, because that wouldn't be something that would keep it balanced, right? We could again check it with the 1/2. 1/2 squared on the top would be 1, and then it'd be 1/4, so that wouldn't work out either. Let's go back to our original strategy that we had. If I am considering, again, this is improper, which is why everything I do improper, I put in brackets, just as a good question. I do it because it's intuitive. I put it in brackets because we know it doesn't work. That doesn't mean it's not a good place to start from. It just means it's a horrible place to stop. Okay? So if I wanted to try to plug in infinity, like negative infinity, I could do that. But we already know that's not going to work out so hot. Because if I do that, I'm going to end up getting a whole bunch of infinities and then squarings of infinities. And I don't even know what that means. But it's probably going to be big. But then the bigness is kind of, I lose track of what is what. Like, this is not awesome, but it's an okay and intuitive place to start. So what we're going to do is we're going to start here. We're going to realize that this doesn't work out so hot because I can't plug in infinity, but I can plug in big numbers. Do we all agree with that? I've got 2 people nodding in a room of like 40 people. Can I plug in big numbers for x? Is that okay with everybody? All right, specifically here, I'd want to plug in big negative numbers, right? So it wouldn't, so I'd plug in big negative. Okay, so I'm not going to do it with that. I'll plug in big negatives. Negative big, great. And I could do that with specific numbers too, but then I've got to recognize that any number I choose will not be big enough towards the negative, and that's not awesome. I could try a whole bunch of values and see what that gets close to. We call it the method of exhaustion. It makes a forever long list. Not an awesome strategy if I only have 20 minutes for a quiz, because you can't fit a forever long list into 20 minutes. In fact, you can't do it at all, right? Take too long. So we've got ideas here. We know there's a list. We know we're considering big numbers, but we can kind of play. If I plug in a big number to the negative, big number to the negative, and I raise that to the 5th power, is that going to be bigger or smaller when I do it to the 5th? In terms of size. Let's do negative 1,000 to the 5th. That's a lot of zeros, right? So in terms of size, it's gotten very big, bigger to the negative. And then this over here has gotten bigger to the negative as well. Actually, that one made positive. All right, so we've got some bigness that's happening where things are getting bigger and bigger and bigger and bigger. Primarily, this thing is getting the biggest. That reminds me of the technique we did in class. Let's stop playing with big numbers. Big numbers are tough. There's no end to the big numbers. Instead, let's scale everything back. So here becomes the little technique that we said. It's a very creative change in perspective. Let's scale everything down in terms of that biggest driver. If x to the 5th is the biggest driver and causing things to become very, very big, let's scale it down. And we'll do it to the denominator because multiplication on the numerator and denominator keeps it all balanced. And we still have our limit. All right, what can we do from here? Was it? Factor? I've already got it factored. It's already written as multiplication. Okay, what do we call this applying? Distributing. We could absolutely distribute it. So now we've got the limit as x approaches negative infinity of, this is division by x to the fifth. So x to the fifth divided by x to the fifth should be 1. Nice. 4x squared divided by x to the fifth, that's 2 x's, and I'm dividing it by 5 x's. So I can do a little thing off to the side. 2 x's divided by 5 x's. Do we agree we can cancel some of those out? All right, we'll cancel out these 2 and these 2. That leaves me with 1 and 3 x's on the bottom. Okay, so I'm starting to get a little bit of traction here. That's limit as x approaches. Oh, I already wrote that, didn't I? Let's go back to where I was writing it. All right, so this becomes 4 and then 1 over 3 x's. Got it. On the denominator, this one is hard. This one's a little bit tricky. Right? How do I multiply this into a square root? A little tricky. Here's a cool way of doing it. Let's, instead of making this x to the fifth, let's make it square root of x to the 10th. Same meaning, right? Different appearance, same meaning. All right, now I can multiply that all in. So x to the 10th in a square root divided by x to the 10th in a square root, that should be 1 in a square root. And 8 x to the 7th over x to the 10th, that's 7 x's over 10 x's. I can simplify that out a little bit. I'm going to get 8. And then I've got 3 more x's on the bottom. How do we feel about this? This is the tricky part about dealing with square roots, right? The idea of how do you multiply inside of square roots? This is really drudging in some difficult algebra, but this is just still algebra. All right. Do I want to make a list? That's going to be exhausting. Instead, let's use our logic to run the list further than we could ever do it with a calculator. Ready? I'm going to make x big and negative. All right, so that's going to be 1 plus 4, 1 over negative big to the third. We all agree that's what happens when I make x big. I plug in a big negative number. All right, let's do that on the denominator now. On the denominator, I have square root of 1 plus 8, 1 over negative big cubed. All right, negative big cubed is going to be negative and big. Very good. 1 divided by negative big is going to be negative 1 over big, or negative small, right? So this is going to become small. Small times 4 is big or small? Small. So this has become now 1 minus small. And on the denominator, we're going to have square root of 1, again, minus small for the same reason, right? Now, if I let this run on to forever, what's the smallest size number we have? 0 is the smallest size number. So this becomes 1 minus 0 at the end of the forever long list. And this becomes square root of 1 minus 0 at the end of the forever long list. Simplify that up and you get 1. If we want to double check the intuition, we can go back over here now that we know how the algebra is going to work out. This is the same magnitude as this after I square root it, right? So I think that should work out where that's going to cancel away. Now here's a difficulty I have. I think it might answer your question. If I look here, that's negative, right? Do we all agree that if I make x really, really big and negative, that that top part becomes negative? This one down here is positive, right? Where did I go wrong in this math? Because this should come out as negative over positive, which is negative. I got a positive. That doesn't work.
Because the exponent for the top part of x is 5, which is an odd number, it's always going to change between positive and negative.
That is absolutely true. So that's why the numerator is going to turn out to negative, but my math came out as positive. So I messed up somewhere. Where did I mess up?
Plus or minus square root.
That's it. Right? if I want to create a square, I have to make sure I bring in its opposite in the same way that if I want to add 2, I have to bring in -2. The same way I want to multiply by 2, I got to divide by 2. Right here, I brought in a squaring of 5 to make 10. And I forgot the plus or minus square root. So we've got to run the plus or minus square root through this entire thing, which meant the answer was plus or minus 1. And so we go back over here, double check it, and realize that the answer has to truly be -1. Because that's where the original problem would have trended towards if we considered the forever long list. Lots to consider in these problems, right? Lots going on behind the scenes. Go ahead.
Okay, can you tell me about that last part? Like, how do you figure out that -1 was supposed to be the one that works?
I had to go all the way back up here and consider the original list. Right? In this one here, if I imagine plugging in big negative number, everything that I've got inside of the black here, right? That was going to be big negative over whatever comes out of a square root has to be positive. So that's how I was able to double check it, right? Because the answer was one of 2 different things. Which one is it? I don't know. Let's try some numbers. Very clearly becomes evident that the -1 is what we're playing with.